This conference will now be recorded.
Hello guys, today we'll speak about the rates of reaction and the factors that are affecting the rates of reactions. First of all, as you know, the speed of different chemical reactions varies hugely. Some reactions are very fast and others are very slow. The speed of a reaction is called the rate of the reaction. As you can see from the following pictures, some reactions can happen really fast. Some of them are proceeding for a long time, such as in case of rustic. But not all collisions are successful. In order to have successful collisions, particles should have minimum energy, which is called activation energy. The rate of a reaction depends on two things: the frequency of collisions between particles and the energy with which particles collide. If particles collide with less energy than the activation energy, they will not react. The particles will just bounce off each other. Anything that increases the number of successful collisions between reacting particles will speed up a reaction. But which factors are affecting the rate of reactions? First of all, temperature, then concentration, surface area, catalyst, and the intensity of the light. While we are increasing the temperature, the rate of reactions are increasing. Increased concentration of dissolved reactants and increased pressure of gas reactants also increasing the rate of reactions. Increased surface area of solid also is increasing rate of reactions as well as catalyst. Reactions do not proceed at a steady rate. They start off at a certain speed, then get slower and slower until they stop. As the reaction progresses, the concentration of reactants decreases. This reduces the frequency of collisions between particles, and so the reaction slows down. If you will take a look at the following picture, you will see that initially you are having 0% of products. But as the time proceeding, the amount of products are starting to increase, but the concentration of reactants are starting to decrease. We can show it in a graph as well as. According to the graph, at initial points, the amount of products is 0, but the amount of reactants are higher. As you can see, after a while, the reaction is stopping. It's due to the fact that there is no more reactants in order to react with each other anymore. The steep slope is showing us the fastest reaction. The shallow slope is showing us the slower the reaction. And when it's constant, no reactions happens. Measuring the rate of reaction means measuring the change in the amount of reactant or the amount of a product. What can be measured to calculate the rate of reaction between magnesium and hydrochloric acid? When magnesium and hydrochloric acid are reacting, we can calculate the amount of reactants. How do they decrease by the time? Also, we can calculate the amount of magnesium chloride produced in gram per minute, as well as the amount of hydrogen products formed in centimeter cube per minute. As we know, hydrogen is a gas. Which equipment is needed for this reaction? First of all, we are having a conical flask. In conical flask, we are having magnesium and we are adding hydrochloric acid. As you know, as a result of this reaction, hydrogen gas will be produced, and hydrogen gas will be collected by gas syringe. Well, we can read the volume of hydrogen gas formed here, according to the readings of a gas syringe. And the amount of products of hydrogen gas formed over the time will give us a clear idea about the rate of reaction. In order to calculate the rate of reaction, we can use such graphs. For example, how can the rate of reaction be calculated from a graph? The gradient of the graph is equal to the initial rate of reaction at that time. For example, if at 20 seconds we are having 45 centimeter cube of this one which is produced, it means that overall we had 45 centimeter cube of hydrogen gas formed in 20 seconds. That's why rate of reaction is equal 45 over 20 seconds, and it will give us 2.25 centimeter per cube over seconds. And this is illustrating us how rate of reactions are changing over the time. So You can check yourself and you can complete the sentences about rate of reactions. Changing the temperature affects both the frequency and energy of collisions. Changing the concentration affects the frequency of collisions of dissolved reactants. And changing the surface area affects the frequency of collisions involving a solid reactant. Okay, let's speak first of all about the first factor which is affecting the rate of reactions. It's the temperature. How does the temperature affect the rate of particle collision? You know that when the temperature is increasing, it's increasing first of all the rate of diffusion. If the rate of diffusion is increasing, it means that the particles are colliding with each other more faster. The higher the temperature, the faster the rate of reaction. In many reactions, a rise in temperature of 10 degrees causes the rate of reaction to approximately double. Why does increased temperature increase the rate of reaction? First of all, at a higher temperature, particles have more energy. This means that they move faster and are more likely to collide with other particles. When the particles collide, they do so with more energy, and so the number of successful collisions increasing. Why a vector is more likely to run down more quickly in cold weather? At low temperatures, the reaction that generates the electric current proceeds more slowly than at higher temperatures. This means that batteries are less likely to leave enough current to meet demand. The reaction between sodium thiosulfate and hydrochloric acid produces sulfur. Sulfur is a solid and so it turns the solution cloudy. How can this fact be used to measure the effect of temperature on the rate of reaction? For example, how does temperature affect the rate of reaction? If you will take a look at the time and if you will take a look at the temperature, you will see that if the rate of reaction it was used up 110 seconds at 25 degrees, at 50 degrees it was 30 seconds. What about concentration and pressure? The higher the concentration of a dissolved reactant, the faster the rate of reaction. Why does increased concentration increase the rate of reaction? At higher concentration, there are more particles in the same amount of space. This means that the particles are more likely to collide and therefore more likely to react. If you will take a look at the picture, you will see that when you are having less particles, less concentration, there are less probability of them to collide. But when it comes to the high concentration, you are having more probability of them to collide and to get successful collisions. How does concentration affect the rate of reaction? We can see in the reaction of hydrochloric acid with magnesium ribbon. The reaction between magnesium and hydrochloric acid can be used to investigate the effect of concentration on rate of reaction. If we will increase the concentration of hydrochloric acid in this reaction, it will increase the rate of reaction. That is why more hydrogen gas will be released in a given time. Why does increasing the pressure of gaseous reactants increase the rate of reaction? As the pressure increases, the space in which the gas particles are moving becomes smaller. The gas particles become closer together, increasing the frequency of collisions. This means that the particles are more likely to react. Let's come to the surface of area and catalysts. How do they affect the rate of reactions? Any reaction involving a solid can only take place at the surface of the solid. If the solid is split into several pieces, the surface area increases. And of course, it will affect the rate of reaction in a way of increasing. This means that there is an increased area for the reacting particles to collide with. The smaller the pieces, the larger the surface area. This means more collisions and a greater chance of reaction. If you will take a look, in the first picture, you are having a big cube and you are having less area of interaction with hydrochloric acid molecules. But in the second picture, you are having more surface area in order to collide with the particles of hydrochloric acid. So that's why the rate of reaction will increase in the case of second picture. Marble chips are made of calcium carbonate. They react with hydrochloric acid to produce carbon dioxide. The effect of increasing surface area on the rate of reaction can be measured by comparing how quickly the mass of the reactants decreases using marble chips of different sizes. If you will take a look, we can use a balance in order to check how fast the mass of marble chips are decreasing. And the last one, catalyst. Catalyst is also increasing the rate of reaction. Catalysts are substances that change the rate of reaction without being used up in the reaction. Catalysts never produce more product, they just produce the same amount more quickly. Different catalysts work in different ways, but most lower the reaction's activation energy. If you will take a look at this graph, you will see that we are having reactants and we are having products. By the way, this reaction is exothermic reaction. In order for reactants to turn to the products, they should have minimum activation energy, which ones they have to overcome, and they have to turn to the products. But catalysts are increasing the rate of reaction by providing second pathway with low activation energy, which means that more particles will be able to collide and more particles will be able to make successful collisions and will turn to products in a given time. Many catalysts are transition metals or their compounds. For example, nickel is a catalyst in the production of margarine, hydrogenation of vegetable oils. Iron is a catalyst in the production of ammonia from nitrogen and hydrogen, which we are calling hybrid process. Platinum is a catalyst in the catalytic converters of car exhaust. It catalyzes the conversion of carbon monoxide and nitrogen oxide into the less polluting carbon dioxide and nitrogen, in which way we are protecting our Earth. Why are catalysts so important for industry? Products can be made more quickly, saving time and money. Also, catalysts reduce the need for high temperatures, saving fuel and reducing pollution. Catalysts are also essential for living cells. Biological catalysts are special types of proteins called enzymes.